Question number 5. Perform the division and write the answer in the form A plus B iota. Solution: 1 plus iota divided by iota. Divide and multiply the given question by iota. So here we get iota plus iota into iota, iota square divided by iota square. As we know that the iota square is -1, so here we get iota plus -1 divided by -1. Now we can write it iota -1 divided by -1, multiply and divide by -1, iota -1 divided by -1. So here we get minus into iota, minus iota, and minus into minus plus 1 divided by -1 into -1, we get 1. So we can write it 1 minus iota. It is in the form A plus B iota, which is the answer. Now the second part is 13 divided by 5 minus 12 iota. Solution: so divide and multiply by its conjugate. Conjugate of 5 minus 12 iota is 5 plus 12 iota. So we can write it 13 divided by 5 minus 12 iota into 5 plus 12 iota divided by 5 plus 12 iota. Now multiply 13 5s are 65 plus 13 12s are 156 iota divided by A minus B into A plus B formula is here, so we can write is 5 square and minus 12 iota square. Further we get it we can write it as 65 plus 156 iota divided by the 5 square is 25 minus 12 12s are 144 iota square. So we can write it 65 plus 156 iota divided by 25 minus 144, and iota square value is -1. So we can write it 65 plus 156 iota divided by 25 plus 144, minus into minus. So we get here 65 plus 156 iota divided by 144 plus 25, we get 169. So we can write it 65 divided by 169 plus 156 divided by 169 iota. Now we can simplify it. 13 5s are and 13 13s are 5 by 13 plus here 13 13s are and 13 12s are. So here we get 12 divided by 13 iota. It is in the A plus B iota form, which is the answer. Solve part 3rd by yourself. It is your homework. Now question number 6. Prove that the sum as well as product of complex number and its conjugate is a real number. So in this we can take any complex number because it is not given in the question. Let z equals to a plus iota b be a complex number. So its conjugate will be z conjugate a plus iota b conjugate. The conjugate sign changes the imaginary part sign. If it is plus, we will write here minus, and if it is minus, then we will write here plus. Now according to the given condition AGC, according to the given condition, sum of these z plus z conjugate. So write it a plus iota b plus a minus iota b or b iota, what you can say like this, a minus iota b. So these imaginary part cancel with each other. We get a, which is a real number, which belongs to the real number. We have proved the one part. Now product z into z conjugate, which is equal to a plus iota b into a minus iota b. Now a plus b, a minus b formula, we can write a square minus iota b square. Here we get a square, and minus here we get iota square b square. We know that the value of iota square is minus 1, so we can write it a square into minus 1 b square. So a square minus into minus plus b square. A square plus b square. Look, is there any iota sign? No. So it is pure real number. So according to the question, we have proved that the product of the sum and product of complex and its conjugate is a real number. We have shown it. Question number 7. If z1 is equal to 1 plus 2 iota and z2 is equal to 2 plus 3 iota, then evaluate z1 plus z2 whole modulus. First of all, we will find z1 plus z2. So we can write 1 plus 2 iota plus 2 plus 3 iota. Add the real part with real part, 2 plus 1, 3. And imaginary part with the imaginary, we get 5 iota. Now take modulus of z1 plus z2. So 3 plus 5 iota modulus. So how we can expand this modulus? Take the square of the first and the square of the coefficient of the imaginary and take the square root. This is called modulus. So here we get 9 plus 25, and 9 plus 25 we get what? 34 under the root. This is the answer. Now part second is z1 into z2 modulus. So try it by yourself. First of all, multiply z1 with z2 and then take its modulus. The third part is z1 divided by z2 whole modulus. So we can write it. Z1 value is 1 plus 2 iota divided by z2 value is 2 plus 3 iota absolute. So we can write it. First of all, we will show this. So first of all, what we are going to do, z1 divided by z2. So 1 plus 2 iota divided by 2 plus 3 iota. Multiply and divide by the conjugate of the denominator, which is 2 minus 3 iota. 1 plus 2 iota divided by 2 plus 3 iota into 2 minus 3 iota divided by 2 minus 3 iota. Now look, 1 into 2 we get 2, 1 into 3 we get minus 3 iota, 2 into 2 we get plus 4 iota, and 2 into 3 we get minus 6 iota square, divided by here we get 2 square minus 3 iota square. Now look, 2 4 minus 3 we get only iota, and here minus 6, the iota square value is minus 1. Now here we get 4 minus 9 iota square. So multiply this minus with this minus, we get 2 plus iota plus 6. Here 4 minus 9 iota square value is minus 1. So we can write it 2 plus 6, 8 plus iota, and here minus into minus plus, we can write 4 plus 9. So we get 8 plus iota divided by 13. So we can write it 8 by 13 plus 1 by 13 iota. This is the value of Z1 divided by Z2. Now we will take the modulus of both sides and then we will solve it. So take the modulus. Take the modulus on both sides. Z1 divided by Z2 modulus equals to 8 divided by 13 plus 1 divided by 13 iota modulus. So how we can expand this? Take the square of the first plus the coefficient of the imaginary part square and under the root. So now we get here 64 by 169 plus 1 divided by 169 whole under the root. We can write it, take the LCM 169, so 64 plus 1 under the root. We can write it 65 by 169 under the root. So we can cancel it by what? By 13 5s are 65 and 13 13s are. So here we get 5 by 13 under the root. This is the answer of the given question. Now question number 8, part first. Separate into real and imaginary part. Part first is 2 plus 3 iota divided by 5 minus 2 iota. Solutions. How we can solve it? Divide and multiply by the conjugate of the denominator, which is 5 plus 2 iota, 5 plus 2 iota. Multiply these two. 5 2s are 10, 2 2s are 4 iota, and here 3 5s are 15 iota, and 2 3s are 6 iota square. And we can write it 5 square minus 2 iota whole square. Now here we get 10, 15 plus 4, 19 iota, and here we get 6 iota square value is minus 1, divided by here we get 25 minus 4 iota square. Now look, we can write it 10 plus 19 iota minus 6, minus 1 into 6 minus 6, and here we get 25 minus 4, and iota square value is minus 1. So further we can write it 10 minus 6, we get 4 plus 19 iota divided by 25 minus into minus plus 4. So we get, further we get 4 plus 19 iota divided by 29. Now write these separately. A is 4 by 29 plus 19 by 29 iota. The real part is 4 by 29, and the imaginary part is 19 by 29. Now look at part second. 1 plus 2 iota whole square divided by 1 minus 3 iota. So 1 plus 2 iota whole square can be written as 1 square plus 2 iota square plus 2, 1 into 2 iota, 1 divided by 1 minus 3 iota. It is further can be written as 1 plus 4 iota square plus 4 iota divided by 1 minus 3 iota. Now iota square value is minus 1, so minus 1 into plus we get 1 minus 4 plus 4 iota by 1 minus 3 iota. 1 minus 4 we get minus 3 plus 4 iota divided by 1 minus 3 iota. Now multiply and divide by the conjugate of denominator, which is 1 plus 3 iota. So when these two multiply, we get minus 3 minus 9 iota plus 4 iota plus 12 iota square divided by 1 square minus 3 iota whole square, which further we can write it minus 3 minus 5 iota plus 12 iota square value is minus 1 divided by 1 minus 9 iota square. So we get minus 3 minus 5 iota, minus into minus we get plus minus 12. So minus 3 minus 12 we get minus 15 minus 5 iota, and here iota square value is minus 1, so put minus 1, so minus into minus we get plus 9. So here we get 10 and minus 15 minus 5. So now write it minus 15 by 10 minus 5 by 10 iota. So we can cancel these two, like 5 3s are and 5 2s are. Here 5 1s are and 5 2s are. So what we get? Minus 3 by 2 minus 1 by 2 iota. So the real part is minus 3 by 2 and the imaginary part is minus 1 by 2. Part third is your homework. Try it by yourself.